So everyone, thanks for attending the talk. I'm Lior Lieberman. This is Erik. And we're going to introduce ourselves a little bit better down the road. But yeah, we had planned actually for 35 minutes. We didn't know Istio is 25, so we're going to run through all the content real quick. But before everything, I want to start with a story. So imagine a coffee shop, right? When everyone needs to wait in line to get their coffee. Now, look at this person over there, right? It's throwing requests over the barista. They want their cappuccino extra hot, single shot. They want it lactose-free, which is, by the way, my usual drink. But I'm not alone, right? There are other people in the coffee shop. People are waiting in line. And these people are getting mad. Why is the service taking so long? This sounds pretty inefficient, right? Now, to fix this, we spin up self-service coffee machines, right? Customers can make their own coffee, faster service, happier customers. Well, this is only in theory, because not everyone know how to use their machine properly. Some burn coffee, some break the grinder. Other one just spill milk everywhere, and suddenly nobody can make coffee anymore. And where am I going with all this coffee analogy everywhere? So, hey everyone, I'm Lior Lieberman. I'm engineering lead at Google. And this is Erik Parienty, director of engineering at Riskified, and my previous boss. And today, we're going to tell you some of the challenges we had when we scaled Istio in our organization. And these challenges were not unique to us. What happened when we tried to offload responsibilities from ourselves, the platform engineering team, to the developers? Why did we struggle so much to let the developers grind their own beans? And how did we almost end up with complete disaster and overflowing espresso machines? And before I hand it off to Erik to talk about more important things than coffee, a different Erik with C is posting, or was posting, it's quite old, recommending an article recommending to uninstall Istio. And Erik had 2K supporters. And these things happen because Istio is often very intimidating to onboard. It's pretty complex to operate. So hopefully we're going to show you some ways to simplify it. But just quick disclaimer, right? A lot of the Istio Day and a lot of talk here are talking about ambient. All of this work happened before ambient. So before you go and implement whatever we implemented, you also should look at ambient, see if it can potentially simplify things even more. And yeah, over to Erik.
So hi everyone. I'm Erik Parienty, Director of Engineering at Riskified. As Lior mentioned, we work together at Riskified, and we thought it'd be interesting to share how we experience with Istio in general, how we tackle the challenges the system presented to us. First, a bit about Riskified. Riskified is a category leader using AI to fight e-commerce fraud. We work with the largest e-commerce brands in the world to fight fraud and policy abuse at scale, helping them with more customers, accept more orders online, and retain more revenue. In the technical aspect, we handle 25K requests per minute, over 1K microservices running in Kubernetes, and our system review over $114 billion annually. But that's not why you are here, right? You came to hear our relatively small company starting to work with Istio and successfully scale with it. Returning to the coffee shop. In this analogy, the coffee machine represents the new service, the baristas are the platform engineers, and the customers are the developers. Just like in Istio coffee shop, we want to empower developers to manage their own service configuration in Istio. But if we give too much control without guardrails, we risk outages, security issues, and broken services everywhere. I often hear from colleagues and professional firms that Istio is complicated. And at high scale, it becomes even more difficult. So much that some organizations abandon it in favor to other solutions. On the other hand, I also speak with colleagues who want to use Istio at scale, but struggle to implement it properly. I once heard someone say, the time that took me to learn Istio is equal to the time it took me to learn everything I know in this area. And here is the same Erik from before. Says a very similar thing. Sounds extreme? Not necessarily. At Riskified, we chose Istio years ago. And like any new technology, we encountered challenges, especially when it came to scaling our R&D organization while using Istio.
Yeah, so why did we choose Istio, right? Four main things. I guess, common for a lot of people here. MTLS, traffic splitting, traffic mirroring, and observability. Now, MTLS, we were preparing for IPO. We had to introduce, you good? We had to introduce strict identities for every service and to reduce risk if one service is compromised. So MTLS was one thing. The other thing was traffic splitting, right? Again, we wanted to traffic split based on header, based on path. So for example, service V2 of service C, we want to only have like merchants A request to this service. So we had pretty similar cases. One important thing we had is traffic mirroring case. We were using a lot of classifiers. Every classifier were used to assess whether a transaction is fraud or not, whether a subsequent feature of a transaction is fraud or not. So we needed to mirror the traffic to the shadow service and kind of assess how the classifier is performing. And lastly, what happens to a request that is coming to the cluster, where most of the time we're spent? And we're committing to give an analysis in under 1 second whether the transaction is fraud or not. So we spend a lot of time over this dashboard understanding where the request, where most of the time the requests were spent. So again, I read the blogs, read everything. Everyone just recommending to install Istio and relax. And I gotta say, Istio installation is impressively simple, but the operation is anything but simple. Because it's just complex, we had steep learning curve, and developers were dependent on us. We couldn't just get it into self-service and let them use it. And later, we'll try to add Istio to the self-service as well. But before we explain what happened and our journey with it, I want to just align the architecture a little bit.
Before I start to explain how the self-service platform is working in Riskified, I want to explain why developer independence is a principle I deeply believe in, and how it challenges us when we introduce Istio in our system. Developer independence significantly improves efficiency and productivity. Developers who want to make changes don't need to wait for someone else to make them coffee. They don't need approval to add milk or to use lactose-free milk like Lior drinks. It's much easier to manage monthly and quarterly work plans when teams are not dependent on each other, especially when they are not dependent on the platform team. Think how a board plan looks like when 10 teams have a task dependence on the platform team. Now, what about 20? Let's be honest. There will be always fewer platform engineers in the organization than needed. So let's be dependent on them on the daily tasks. But there is another perspective. When a developer is dependent and manages the entire life cycle, from code to production, they are also the ones who will wake up in the middle of the night if the service has an issue. And what's the advantage of that? If they wake up in the middle of the night, the fix will happen immediately, or at least the next morning. Now we got quality. I want to tell you a short story from my past that I use quite often. I used to work in a NOC, and one night I got an alert that the service wasn't responding. I checked the details, I saw it's a new service launched that day, and I woke up the on-call engineer, and he told me restart the server. Remember, servers? So I restarted it, and it fixed the problem. Of course, I opened a ticket for the developers to fix the problem, and I told all my colleagues, if the issue come again, just restart the server. I already left that job. After a few months, I spoke with a colleague of mine, and he told me they are still restarting the server every night. So this is summarized how developer independence is something very important, something I really believe in. Now back to our architecture, how we deploy in Riskified. When we were small and started working with Kubernetes, we knew we had to find a way to allow developers to work independently on Istio and Kubernetes, so we will not be a blocker. So how we can maintain it? This is how. We build a platform for the team to work completely independent. Let's see the high level of it. The development team may have several application-specific code repository they wish to use. However, there will be only one repository for Kubernetes configuration. This is the repository that Argo will reference. In our case, it will usually store the Helm charts. You can see that there are repositories for service A, B, and C, and they are reflected as application in Kubernetes. In each application folder, we have a chart YAML. In the chart YAML, we have a field called dependencies pointing to the chart we are consuming. In our case, it's the Riskified service, which the platform engineers are managing. We also have a value files inside, and additionally, if the charge is extendable, if the Riskified service does not yet support a specific object, development teams can add it under the template folder. Now we go to the CI and high level, no need to go deep. What happens if it's a branch or pull request? Developer merges code and it will trigger a CI that builds the artifact and push it to a repository. One of the steps of the CI is to push the new tag version to the application repository, the values file from before, remember? Now we have a repository with the new artifact version. Argo CD will see the diff, and the pipeline will send a sync command to it, so it will be applied to the cluster. Gradually, developers start to ask more control. They ask defining CPU, memory, affinity, deployment type, and much more. When we reach the communication aspect, things become more complicated. How do we enable developers to work in Istio in an easy way? So let's integrate Istio in our self-service platform. Let's imagine we have a self-service kiosk in our imaginary Istio coffee shop, represent our Helm chart platform to make it simple. The first object, the gateway, has its name. It's defined the gateway for us. It specifies which domain I'm willing to accept from the outside and which port the Istio gateway will listen for incoming requests. At Riskified, we have cases where microservices needed to get requests from outside the clusters. But the gateway is strictly a configuration file. We need to deploy real envoy to expose them to the outside world. We thought a lot about whether to let developers raise the gateway by themselves. However, as we experience with our service, we will find ourselves with many envoys and gateways. Very high availability, but also very, very expensive. Istio offers us the option to deploy a single envoy deployment and layer multiple gateway on top of it. However, it will give us only one entry point to the cluster, which becomes a single point of failure. A crash loop or resource shortage in envoys could bring down the entire production environment. This solution is less HA, but more resource efficient. So we decided as a platform team, we will take this trade-off on our level. Depending on our system, if we have a service with significant traffic spike, we will feel more comfortable exposing it as a separate gateway. Therefore, we decided to set up Istio gateway as a platform. It serves as an existing infrastructure that can be registered and utilized. So gateway are managed by the platform team, and dev can utilize it. For now, we have nothing managed by dev from Istio side. Let's move on to the next object and examine which side it belongs to. This one is the main course. This object caused us the most trouble and take us the most responsibility of the ROM. This object is called virtual service. It's responsible for the requests that reach the service. They came from outside through the gateway. They come within the cluster, traffic splitting, retry mechanism. This object plays a central role in how traffic is managed and routing within the system. Just from the name of the object, virtual service, it makes sense to put in the kiosk for creating a new service. This way, each service will be responsible for its own networking. It seems like a very clean and elegant way. In this configuration, if I want to update a configuration in a risk-free way, I immediately know where to go. There is a clear order, a standard, and I won't get lost. However, after we made this change, the whole coffee shop burned down. What happened here?
Let's dive in, right? One developer is ordering a virtual service, right? Asking for all the traffic with the prefix /API to go to the API _service _v1, their service. Until now, all fine. But a different developer is ordering a different virtual service, asking for all the traffic with prefix / to go to their service. Now, An API request with /API/order, which backend would it hit, right? Which rules it will follow. Now, Istio supports virtual service merging on the same host when configuration is configured across virtual service. But there's one thing to note, and this one's important. So the order of evaluation of rules, essentially, is maintained within the object, but the cross order between object is undefined. And I'll repeat that. When you have two virtual services, the cross order of the rules is undefined. And this essentially means that every developer in the organization can steal requests to other microservices on the same host. Now, I want to clarify one thing. The fact that it's undefined means that a lot of times where a different virtual service, in our case, the second developer that ordered the second service will order another, will just deploy another virtual service. Everything will still be fine because it happens to be maintained. But oftentimes, we wake up at night trying to understand about the config, what has changed, and it will be very, very hard to determine. And I think, if I remember correctly, when we looked at Istio code, this is determined by the creation timestamp of the virtual service, so Istio kind of tried to protect you on that. But that's essentially a great recipe for burning the coffee shop. So what's the easiest move? Let's remove the virtual service outside of the self-service machine. And now gateways and virtual service will be maintained by the platform team. But one day developers coming to us, they have the virtual service with API Riskified.com. They want to do traffic splitting, so the platform team is doing traffic splitting for them. Now a different developer is coming and they want to do something else. And fast forward, this object already contains more than 1,000 lines of code. And this is the most sensitive object of the system. This is where the traffic from external customers getting into the cluster. Now, making changes there were extremely terrifying, and these changes can happen very frequently, especially in a growing organization. So we're back to the original problem, right? We are the bottleneck again, and we have a problem with this object, this virtual service object. On the one hand, it's too powerful, has too much responsibilities, but it controls what coffee you want, what milk you want. So we really wanted to get it to the developers to own. But it also controls the water temperature, the pressure of the machine, and we want it to be managed by the platform because it can have wide impact. So it looks like we have real no choice but cutting the object into two. Yeah, I mean it. It is possible. So every part of the virtual service, the same virtual service, will manage by different part of the organization. And let's see how it looks like. So you see on the right-hand side, the dev-owned virtual service would be the place where the devs define what they need: traffic splitting, weight-based routing, a lot of the configurations that is related to the service itself. What happens to request will be defined there, but the hosts field will be empty, meaning that this configuration is not registered anywhere. And this is why we have the second virtual service, right? This virtual service owned by the platform, and this will manage the pass-based registration, specifically in this case for the host API Riskified.com. And you can see that delegate, which is what enables this splitting virtual service into two. The delegate, virtual service delegate, lets us delegate the decision to a different virtual service. And one last thing is, if we want, because we said it's, this is what happened.
They will believe you.
It'll be back.
Continue.
Yeah, we want to register. We want to register the same virtual service as well in the mesh. So it means that if a different service is sending requests to the same service, we want to maintain the same dev-owned decisions. So that's why we're deploying a different order, registering in the mesh, and not just in the gateway. Now, last thing, and to improve the life even more, make it full developer independence, we did automate a pass-based registration with a nice UI where developers can just submit route update requests, and we can just approve it from GitHub or Slack bot. Now, let's move to the next object, destination rule. This was this where we can maintain LB policies, TLS, but essentially it does not affect how service is selected. So it was pretty safe to get it into self-service kiosk, and I'm going to shortcut a little bit here because we don't have a lot of time. But we meshed it, right? We got everything. Everything is operating self-service. We're pretty satisfied, but we still have some time for the presentation. And obviously, Istio got us again, right? We had more failures as we grew. Our envoys kept crash looping. We had more and more memory issues. And let's dive in real quick. And I'm going to do it real quick, so I'm available for question after that. But let's assume a simple layout with 4 pods, right? And these 4 pods not necessarily communicate with each other, but each one knows about each other. Now, notice what happens when we add 2 more pods to the cluster. Every pod that goes up and down requires a full configuration change, regardless of whether it needs to communicate with each other. Now, imagine deployment process with 500 pods. How much load would it add on the system? Let me tell you. It will be CPU, it will be network, and it will be a lot of cross-availability zone traffic. Now, this one thing to know, this one was happening before Istio 1.22, where Delta XDS became the default. But even with Delta, we want this situation. We want every service to know only the configuration that it needs to know. And luckily, Istio provides us a way to do so using a CRD, sidecar object.
Sidecar object. Of course, we will release it to developers. Developers will just add the values file, the host list, the service they'll communicate with. The values will generate the YAML file you see in the slide, and the only thing they need is the namespace host list of the egress key. After deploying this object in the cluster, we saw a drop between 70 to 80% in CPU usage and 90% in network during peaks. Also, we noticed the same to all our Istio proxy sidecars. And also the memory dropped. And the most important, no issue in the middle of the night. This is a great way to scale your system using Istio. And now, if a developer is already specifying who they are talking to, why not to have them specify who is authorized to speak with them and to manage authorization? We will gain some credits with security department. So let's add it to the service mesh. How cool is that? Now I want to be clear. Our developers team don't know what is each object. We are setting everything for them. For the developer side, they just need to put the name of the service, and they will get everything in the values as a default. As the time passed, we had some mandatory files like the authorization we are speaking now, but that's it. So where do we stand now? We have a self-service coffee machine, plus separate milk frother only for those who want special alternative, of course. We freed up the bottleneck in the platform teams and maintain developer independence. And we've introduced protective mechanisms so they don't burn the coffee shop by recruiting firefighters as barista. Thank you very much. And honestly, if not long ago I thought Istio was complicated, try building a presentation on Istio for 20 minutes for a broad audience. Thank you very much. Questions?
You get a mic offered there if you need some questions.
Hi, just one question. Yeah, thanks for the presentation. Is there a way, because Istio has all this observability, sometimes it's hard to know the dependencies between services? Because app dev teams, we've got hundreds of microservices. Is there a way that Istio can build this sort of thing for us, or a tool that could do?
There is a new feature with Envoy that is doing it on demand. I'm not sure whether it is supported yet in Istio or not. I know there is an issue for that. But there is another way to solve the same problem where you can generate a metric, and then you can do it in a way where you do not like you run with a metric and then we cut it from the presentation, but like you run a PromQL metric and then you kind of generate, and you have kind of generator where you can understand what services your service communicated with, and then you can iteratively add it to the sidecar. But there is the on-demand XDS, and yeah, you could follow. I can, if you stick around later, I can send you the link to see if it's supported or not. Yeah.
Hi. You didn't go through this in the presentation, but I wanted to know: did you experience anything regarding ambient mode? Since you mentioned the sidecar a trick, let's say, to reduce. Did you experiment with that, or you didn't have time?
No. So like in the beginning, I mentioned disclaimer was all before ambient mode, like all this work before. I'm not a Riskified anymore. But Erik can explain if they are evaluating ambient.
We didn't really start with ambient yet.
Okay, yeah. Yeah, I was asking since in my company we were in the exact same process. Like, we're just thinking.
For now, we don't have pressure to do it, to move. But we will move.
Okay, thanks.
Well, apparently I'm short. Thank you very much for the talk. I'm wondering whether you are using also multi-cluster setup. Multi-cluster setup with Istio.
Multi-clusters.
All the time. Let's follow up later. Sorry.
Well, we'll speak now.
Yeah.
Sorry, guys. Thank you
Thank you so much.
Okay.